Hi friends, welcome to #TechieMit. So good to see you after a long time. So in continuation with the videos as discussed, we'll see multi-threading in Java, the most awaited topic and the most important topic, and it's one of the most uh, discussed and a lot of documentation and a lot of articles are there on multi-threading. So let's go for this important topic. So we'll start with the definition and we'll see how it goes for it. So to start with the thread definition. So basically in multi-threading you should know what is a thread. Thread is the smallest unit of execution within a process. It's the most basic unit of execution. As in the general science term, atom is there. So in terms we have thread. So it is the smallest or basic unit of execution, the most smallest unit of execution within a process you can be considered. An entire program can be divided into multiple threads to perform tasks simultaneously, giving rise to the concept of multi-threading. As a thread is a one unit of execution, so an entire program can be divided into multiple threads. So and then all those threads can be executed independently. So to supplement this concept, we have the concept of multi-threading in Java. So basically a thread executes code in order predefined sequence independently of other codes. So the point to consider here is that the execution of one thread is not dependent on other threads. So each thread can execute it in its own independently. So suppose you have if for a scenario, let's consider that you have two threads, one is the main thread and one is the custom based or user based thread. So the main thread will execute on in its own area, it have its own life cycle, and it will communicate with the other thread. So only the point to note that it can communicate with other thread. One thread can communicate with other threads, but the execution is independent of each other. So uh, it gives the concept that the thread can execute independently. Also the thread executes in the main method, the other threads can be completed on the user specific as I mentioned in this point. So this is regarding about the thread definition. So what is basically a thread and how it supports in the multi-threading concept. So let's move further. Life cycle of a thread. Now consider over here, when a thread is actually started, it's in the new state. So it's like a newborn baby. So it's in the new state. It's the new thread, the new state, and after that it can move into the runnable state. Runnable is just before the running, and from runnable it can go to the running state with the help of run method. Okay. Note, running state is important because in running state the thread is actually active and it can perform the operation as designated and as given. And after that, from running state it can go to the block state. Note, block state is temporary suspension of the currently executing thread that can be done with the help of wait or sleep method. And so from new it moves to runnable, from runnable it moves to running, and from running it moves to block. So these are the various stages it can do. And also, like you can there are some cases in which you can move from one state to another place. So consider from block state you need to move to the runnable state. You have to we can do with the help of resume method and notify method. We have here methods like run, yield. So yield is basically like background running process. And from running it can go to the runnable state using yield. Note here one more important point, is from each stages it can directly move into the dead state. Suppose, so point to be considered here is that if the thread is just newly created, or it is in runnable state, or it is in running state, or it is in block state, it can be directly moved into the dead state using stop method. It's like a hard stopper. So consider a situation like in gym you are exercising, and if there is a on treadmill you press the stop button, it's like hard stop, main stop. So it directly stops its execution, and from the regardless of any state it directly moves to the dead state, means that thread is no longer alive and it cannot perform any operation, and the life cycle of the thread completes of that. So importantly consider that right from when your thread is like newly created, or it's like this is new state. After that it moves to runnable state, from runnable it moves to running state, and from running it moves to block state. So and the various method to move from new to runnable is not any method required, but on runnable there is a run method. So from runnable to going to running state, it contains run method. After that from running state to it can be moved to the block state using wait and sleep method. So wait is like a thread is waiting a specific amount of time for the other thread, and the sleep is that a thread temporarily stops its or suspends its execution for a specific amount of time. It can be specified in milliseconds, so we will see in detail. But to point to consider is that from new it can go to runnable, from running and it can go to move blocked, and it can move from any other state to directly to the dead state. So this is importantly about the life cycle of the thread. You must consider and you must know that how a thread cycle executes, and what are the various methods in it. So let's move further. Thread methods. So thread, as is we see in the diagram, thread is in new state when it's actually created, or it's in by default new state. So after new state, thread can move to the runnable state. It's not actually running in the runnable state, and in running state thread moves to the running state when it's actually active, and it's in this running state it can perform tasks that we can assign to each threads. After that we have blocked. Block, what it does, it suspends when a thread is in block state, its execution temporarily suspended, as we see in the wait and sleep method. So they do not permanently stop the thread, but just for temporarily they suspend so that they can perform some other tasks, and some other things can be done, and post that they can resume their current execution using the resume method and all. After that the final stage is dead state. Thread can enter into dead state after it completes all of its execution of the life cycle, and it's finally into the dead state. So we saw about the life cycle and the thread methods. Now let's move further on seeing how the threads can be implemented and how the threads can be created. So notably in Java there are two main ways in how the thread can be created. First is that it can be created by extending the thread class or by implementing the runnable interface. So I've just shown a small code snippet sample. Like we have taken the runnable and we have provided a lambda for it, so it doesn't take any arguments, and we have just printed the line that's new thread is created by runnable. And after that you can pass the runnable instance in the new thread using new thread. New is the usual constructor, and it internally takes the runnable instance as its parameter, and you invoke the start method in it. After that we have we can extend the thread class. So class thread demo extends thread, so public void run. So after that thread dot sleep method extends thread. So you can see here, so you can just create a thread class, and you can just see over there. So this is important because class dot thread demo extends it. So public void run. There is a different way of the thread creation. So here you use the extends keyword to extend the thread class, and you can use it in by default methods in it. After that, let's finally discuss about, as we know that thread can be created or implemented in two ways: by extending the thread class or implementing the runnable interface. So let's see the point of differentiation and when to use the runnable interface and when to use the thread class. So to start with, what is a runnable interface? Is basically interface. So multiple classes can implement runnable, as the definition goes. And thread is a class. So only one thread class or one thread can be extended using thread class, as per the Java rule, as it doesn't allow multiple classes or multiple inheritance. So the thumb rule is that it's interfaces, so it can be implemented multiple classes, and only one thread can be extended by using the thread class. It has multiple start and run methods, runnable interface, and but correspondingly the runnable thread class has only one method, that is run. And multiple threads share the same object. The point here to note is the multiple threads share the same objects in runnable interface, and each thread create a new object in thread class. So when you create the thread class, there is a new object created in the heap memory for each thread. So according to the memory management, if you consider that, then runnable interface is more memory efficient, or it's more memory efficient as compared to thread class. And finally, if you consider the point when it needs to be used, so it's in most of the cases for implementation of throughout the runnable interface. And thread class can be used ideally memory management is not the only constraint. So let's consider some simple programs and all, you can use the thread class, but otherwise in all cases using the runnable interface is much more suitable. So this video was all about the multi-threading, and I've just given a gist of how what is basically a thread, how is its life cycle, what are the various methods, what are the various ways in it can be created, and as a point of differentiation, when to choose what as a way of creation. So that was all about in this video. So do keep liking, subscribing, #TechieMit. More to come on you on multi-threading and other related topics. Bye for now.